Hi everyone, welcome to the presentation on the topic of NBA data analysis. NBA is a professional basketball league in North America. For our project, we have built a website to help the NBA managers sprint championship, maintain team's competitiveness, find potential young players, and keep the team's salary cap.
This is what our website application looks like. It is deployed to Heroku. The first tab contains a list of clean data generated from our ETL job. For example, for this table, we calculated game duration and play times from time field. Other scores are averaged and summed by player, team, and year. For injury table, we add season and date. We also separate notes field into injury name and status. After the ETL process, all clean data has been saved in the Firebase real-time database, which is a NoSQL database hosted by Google. This NoSQL tool stores data by a key-value pair style and used to store our large amount of unstructured and structured data. Then we link our web application to this database in order to efficiently load and show our data. The second part of our project is data analytics. MVP players and all NBA team players are essentially the same. MVP refers to the best players among all the players, and all NBA team players refers to the 3 best players in each position during the regular season. Therefore, the features to be considered are the players' data and team performance of that season. By joining the player data and team performance and putting it into a random forest classifier, we can finally get a feature importance map. We illustrate the feature importance in histogram and the word cloud. You can find the specific value of feature importance in histogram. In this case, WPCT, which stands for winning percentage, is the most important feature. Or you can simply just check the word size in word cloud image. Let's move on to the champion analysis. When we analyze the champion, we firstly find the feature correlation. As you can see in the heat map, the W and the WPCT have a high correlation, so we drop the W feature. Then we use a similar method to get the feature importance. We found that the WPCT is the most important feature. For further verification, we produce the histogram about the rank of the WPCT and the champion probability, as you can see from the result. The number 1 team in the regular season has more than 50% chance of winning the championship. The teams ranked 4 to 8 have not won a championship. This also proves that the WPCT is an important factor of champions.
Next, we would like to build a model that could help general team managers find the template of their new players after analyzing NBA players' similarity for the last 10 years. After we normalized our data through min-max scalar function, we had 37 columns, and these multiple features would cause a long time analysis and dimensionally cursed phenomenon. Therefore, we would like to compress our features using the PCA function, will scikit-learn, the decomposition library in Python. When component n equals 8, 94% of data variants were kept, which was pretty good. And we could then easily find the template of this new player by computing the distance between different players and figure out the professional player close to him. For example, here, we randomly pick a new player, Orlando Johnson, from the list. This is all the new player name, and we randomly pick this. And then the Jerry Stackhouse is one of the professional players who has the most similarity in NBA performance with Orlando. For visualization, we decided to compress our feature to be 2 principal components, which could be more intuitive to show our results. and 76% variance were kept, which is acceptable in general. Here we use the same Orlando Johnson here, but this time in the same position, Kirk Hinrich became the closed player. Look at this image. Since we have over 5,000 professional players, it is impossible to clearly show all the names on this plot. So we update a new professional player list, which contains only the top 100 basketball players. And it can clearly show the distance between different points and mark the new players we put in. Here is our results. This is Orlando Johnson. Different colors means different positions. So Joe Henrys is the professional players who has the most similarity performance with Orlando.
As an NBA team manager, the team's competitiveness always comes first. Team managers need to be concerned about players' competitiveness and influence on the games. For the players, their influence on the games could decrease as their age increases or they get injured more and more often. In this way, team managers need to be concerned about the influence of age and injury to the players. From these bar plots, we can see the relationship between injury and players and teams. For different positions, most frequent injury types are different. We can see right knee for position F, left ankle for position SF. Looking at these correlation plots, we will be considering future selections for these highly correlated blocks. I will be showing how the code runs for this part at the back end. We tried to train models to predict player stat in the next season based on the physical parameters and injuries. We used cross-validation to train and test the model. We used linear models for these 4 predictions. This injury feature is screwed, so we applied a log transformation on it. The R-squared goodness of fit is reasonably good. Based on our fitted models, we also implemented the feature to launch a demo, where you just need to simply enter a few values here, number of injuries, average points, choose a position and injury type, click submit, and you will get the predicted results immediately. We also predicted next season's offensive rebound and defensive rebound by applying random forest model with visualizations. This part is about NBA salary. Salary is something people are always curious about. Analysis and predictions on salary can not only help keeping the salary cap, but also engage players to set up clear goals and better achievements to get a higher salary. We would like to make a model to predict the player's salary depending on players' performance and their physical conditions. This model will also help NBA general managers to simulate their team ahead of time based on the funds available. The box plot here provides a general idea of NBA salary distribution for each year. 2013 seems to have the highest mean salary, and 2017 has the widest range. The player's average salary is around $3 million. For your interest, in the 2017 season, Stephen Curry got the highest NBA salary, around $34.68 million. Density plot is right screwed by some famous players with extremely high salaries. The heat map has some highly correlated pairs. Might need to consider future selections later. Then we would like to predict salary using the game duration, playtimes, physical parameters, injury, and scores. The model is fitted using a pipeline. Features are normalized since there are big variations among some features. We have trained on some regressor models with tuning, learning from the model. Average field goals made, average point, and age resulted to be the 3 top most important feature which relate to salary the most. Our fitted values are showing the plot, mostly fitted fine except for red dots far away from the line at the bottom. For user convenience, this is the same functionality of what we have demoed on the previous tab. Values can be entered to get a prediction on salary. These are what we have done for this project. We would love to further develop on this topic sometime in the future. Hope you find this analysis useful for NBA team managers and maybe other audiences. Thanks for watching.